Today we are going to discuss color coding of carbon resistors. And in today's discussion we'll see what are the carbon resistors, what is the color code for the carbon resistors, and if suppose a particular carbon resistor is given, its color sequence is known, what resistance it represents, or if the resistance value is given, what should be the correct color sequence for that carbon resistor. We'll also discuss why there is a color coding for carbon resistors. Why do we do that? And finally, one shortcut method of remembering the color sequence for the carbon resistor. Also, we'll discuss that if particular carbon resistor is given, what is the correct way of decoding its color sequence. Suppose a particular has a sequence A, B, C as the different colors there. So correct sequence for a practical carbon resistor is ABC or CBA. How we identify that? So all these we'll discuss in today's discussion. So let's start with color coding of carbon resistors. This is suppose your carbon resistor. Okay. On its body, there will be some colored stripes there. So like suppose I take this as second stripe, third and fourth. Each stripe has its own significance. Like first stripe represents first digit. So first stripe will represent first digit. Okay. Second stripe will represent second digit. Third will represent power of 10. Fourth will represent the tolerance. Okay. Tolerance means it will give you the range of variation for that particular value of resistance. Here, different colors have been assigned different values there. Like different digits or different values you can say. Like black has been given 0, brown is assigned with 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, grey 8 and white 9. So for different colors, their values are here. Then for the tolerance, that is for the fourth band. If it is golden one or gold, then it is 5%. If it is silver, then it is 10%. If no color is there, then it is 20%. If no colored band is there, that means for the tolerance one, then we take its tolerance as 20%. So if you know the value of the different colors, if you know the tolerance, so if color code is given for a particular carbon resistor, you can find its value. So let's apply that one. Suppose for a carbon resistor, the color sequence is given as brown, black, red. This is the color sequence for a particular carbon resistor. That means the first band is say it is brown, second is given as black, and then it is red. We have to find what resistance value it represents. So you see, brown is representing 1. So this is 1. Black is 0. And red is 2. So these are corresponding values of the different colors there. After that, when you want to find its resistance, then as we have said that the first band will represent first digit. So first digit is 1. Second one will represent second digit. So it is 0 here because second one is black here. Third will represent power of 10. So it is power of 10 as 2 because it is the red and it is representing 2 there. So this is the value of the resistance. And since there is no fourth band, it is only 3. So no fourth band is there representing tolerance. So we'll take the tolerance value as 20%. So that means this will be and that much ohm. So it can be written as your 10 into 10 to the power 2 ohm plus minus 50%, or you can say 1 kilo ohm plus minus 20%. It means the value of this one will range from 800 to 1200, as it is 20% tolerance for a resistance value of 1 kilo ohm. So this is how, if the color sequence is given, you can find the value of the resistance. Let's take other way. When we have the resistance value given and you have to tell what should be the colored bands there or color sequence. So suppose resistance value is given as R equals to 4.7 mega ohm plus minus 10%. We have to tell what should be the color sequence here. So for this, we can write first of all, like if it is a 4.7 into 10 to the power 6 plus minus 10%. But we have to write first and second digits intact without decimal. So this will be 47 into 10 to the power 5 ohm plus minus 10%. Now for 4, the color value is, or color is your yellow. For 7, this is your violet. And now the power of 10 is 5. So for 5, it is your green. And tolerance is 10%. That means it is silver. So this will be silver. So this is the color sequence for that carbon resistor, whose value is 4.7 mega ohm plus minus 10%. Here you just take care that if the 2 digits of the resistance are not intact, they are having some decimal sign, don't forget to remove that decimal sign and represent that as power of 10, so that you can get the exact value or proper value of the resistance. Suppose you have been given a carbon resistor whose color sequence is brown, black, red. So if it is there, it is your brown, black and red. This is your brown, this is your black and this is your red. If I hold it like this, then it is your brown, black, red. Okay, but if I just reverse that one, so in that case, what will be? It is your red, this is your black, and this is your brown. That means, if I hold a particular resistance in this sequence like this, it is representing, suppose, your brown, black, and red. Its value, we have just determined that it is your 1 kilo ohm plus minus 20%. But if it is, suppose, taken in a reverse way, then the red will be coming first, then it is your black, and then it is brown. With that color sequence, what is its value, or what resistance value they basically represent? Because if I take sequence as brown, black, red, it will represent a particular value of resistance. But if it is taken as the red, black and brown, its value will be different. But for that particular carbon resistor, it will have only one particular value of the resistance. No matter how you are putting it, resistance value will remain same. So to know what is the exact color sequence of the carbon resistor, you will have to notice one thing. The color sequence which is done, it is done in such a way that they are closer to one particular end. Like you can see here, if this is the carbon resistor, colored band is closer to this particular end. That means they are not in the middle. They will be closer to one particular end. And the end where it is closer, there it will be taken as the first band, second band, third band, like that. So here it was your first, second, third. Like here we have the brown, black and red. it is closer to the end A. If I put it in this way, we will not take red, black and brown as the first, second and third, because they are not closer to this end. It is closer to the end on the right side. So still it will be taken brown as the first, black and red. So this is how you can decode a practical carbon resistor if it is given to you. For a particular numerical, if it is said that this is the color sequence, find its resistance, you can find. But suppose in day-to-day life, you come across any particular resistor, and if you are holding in a different opposite way, in that case the sequence will be different. So there we find out a correct sequence just by considering that which color is closer to one end of that carbon resistor. That will be taken as the first colored band, then it is second, third, like that. Another question, why there is the colors coding there? This is because, as I told you, that the thickness of the carbon resistors will be almost same as the thickness of the refill of your ball pen. Remember, on that small thickness there, if the carbon resistor values are printed, it will be very difficult to read it. Secondly, if there is, suppose you have a bunch of the carbon resistors and you are looking for a carbon resistor of a particular value, then you will have to search in that bunch of resistances your required resistance. So you will be picking up one after the other and you will read what is its resistance value. So it will be really a very difficult task. But if the colored bands are there, in that case, even in the that particular bunch, you'll find it easy to search for your required resistance. Like suppose if I want to get a resistance of 1 kilo ohm. So we know that its color sequence is your brown, black and red. So even if suppose you have a number of resistors there, you will search for the resistor whose first band is brown. If suppose 2 or 3 are there, in that case you will see whether the second one is black or not. Then it is the third one whether it is red or not. So just by appearance also you will be able to pick up easily the resistance of your required value. So this is the reason why there is the color coding for the carbon resistors there. For decoding color code of carbon resistors, you need to know the value of the different colors. That is, what are the values they have been assigned. So you need to remember this sequence, that black is 0, brown is 1, red is 2, like that. And just a shortcut method to remember that color sequences, you remember this line: buy better resistances or your grid bias will go wrong. Buy better resistances or your grid bias will go wrong. Okay, remember this line. And now you take the first letter of each. Okay, so now you see it is your buy, so it is B, it is your black. This B is for brown, this is for red, this is for orange, then it is your yellow, then it is your green, blue, violet, gray and white. Here for this one, you can say that if you take as a statement, then it should be will. Okay, W. But just take that it is say a spelling mistake, or we are trying to write there in the WhatsApp language there. In that case, we have written that one as VIL. This is the one, because so that you can easily correlate it with violet color. Okay, so if you remember this line there or the sentence, you can easily remember the color sequence of the carbon resistors. So this is all for the carbon resistors.